Hello and welcome in, everyone. My name is Brian, and we're here at 1 o'clock BC time. Do a little bit of mathematics. Nice! Hello! How are you doing, my friend? How is the day treating you? Hopefully well. I have had a fucking crazy weekend. It's only Tuesday. I'm already waiting for Sunday when I get a day off. I'm very excited for Sunday. Is that bad? Is it bad that I'm looking forward to Sunday already? I don't know. Oh, I've been awful the last few days. I feel you. It's like maybe different awfuls, but for me it's just been like, it feels like non-stop meetings, and we have hiring right now, and end of semester reports and all that crazy stuff. So I'm just like, my brain is all over the place, and I just can't wait to take a day to breathe, you know?
Time for a pop quiz.
What? 6 plus 9 times 4? Those seem like relatively small numbers. 9 times 4 is 36, and 6 is 72? 72? Is that what we're looking for? Anyway, we got a couple of questions on the docket here. So first and foremost, I would like to finish question number 8 from the 2019 Euclid contest. That'll get us up to date, I think, with question 8 on 2019. So that'll leave us with 9 and 10 to do the rest of the week. And then we've had a couple of questions come in through Discord as well. So, oh no, 4 ads. That's the word. I got 2 on mine. We have a couple questions coming in through Discord, so we'll take a look at getting those kind of set up. And I think we could probably solve some of these. I just need to remember the formula for the binomial expansion. But let's do some warm-ups with some geometry. You know, my favorite thing to do is always work with geometry. That is a lie. And as always, if you guys have some questions, just throw them into either the chat or into Discord. So we did start working on this, but I think we got sidetracked a little while back. So I just erased everything. We're going to start fresh with 8a. We have a circle with center O, radius 1. And we have a quadrilateral ABCD, such that all 4 sides are tangent to the circle. So P, Q, T, and S are going to be our points of tangency. And how does that work? I suppose that means if we were to start at O and drop, we could connect to all of these things, right? We could connect to all of these things and make a 90, I think we can make 90-degree angles there, because those are points of tangency, right? Nice. Welcome back. Welcome back. We missed you. It's crazy. Like, sometimes you get like the low roll with the ads. Like, sometimes I'll get 0 and sometimes you'll get stuck with 5. I don't know how Twitch decides how to randomly assign you a lot or a little ads. But yeah, and it's also this weird balancing act now too, right? Like, I used to be able to, how did it work? Like, I could have pre-roll ads on, and then I could space out all of my ads to like an hour, so they would only happen at the like end of every hour kind of thing. Or if I turn the pre-roll ads off, which tends to be better for new viewers because then they can come in and see what you're working on right away. If I do that, then Twitch wants to run ads every half an hour. So I don't know, it's a bit of a weird toss-up. You have to kind of find a weird balance between how often you want to run stuff. But anyway, that's all management aside. So we have points of tangency. So what else do we know? We know AOB, BOC, COD, DOA. Call of Duty, Dead on the Okay, so we have a couple of things that have 90-degree angles, probably. So all of these angles are the same. All those angles have to add up to 360, which is our rotation around the circle. So I do remember this. All of these have to be 90 degrees. And we know that AO is equal to 3. AO is equal to 3. I was also like, we've been fighting too. Like, we have tenants living in our basement suite, We've been fighting today. Well, the last couple days with like the sink down there, it's like been not draining. So with the plumbers in today, and like that's been all of like a fiasco. Like having to clean out the sink was not, not one of the. I mean, I've cleaned several toilets in my life, but maybe that's worse. I don't know. Cleaning up a clogged sink is not necessarily the nicest thing to have to deal with either. So it's been a day. It's been a day, So please don't judge me for having a glass of rosé at 1 o'clock. Okay. So what should we do? Should we start just connecting some stuff and seeing what we can do? So I'm pretty sure we can probably do this. We know that that's 90 degrees. And should we also connect to T? We could, we could connect it in a couple of different ways. But let's get rid of that 90 degree. We could connect to T and we could connect to S. And I think like, if we zoom in here and maybe start writing some stuff down, I think like this is going to be 90 degrees. This will be 90 degrees because those are tangents, points of tangency. And then this degree up, or this angle up here should also be 90 degrees. Because we know that AOD should divide 360 by 4. So we actually have quite a few 90 degree angles in here. So I'm wondering if Pythagorean theorem might be the way to go. Toilets are worse? Yeah. Put your vote in chat. Are toilets worse? Or are... What's worse? What kind of drain? I've had to clean out like shower drains too. Shower drains are not very pleasant. But I also think it depends on if you've worked in the service industry, it depends, right? Like toilets at home or whatever, because it's like it's your toilet and it's like maybe a little less gross to have to clean it, but like to clean up other people's toilets is a bit weird. It can get kind of messy, I'm not gonna lie. For those of you that have never worked in industry, you should do it for 1 or 2 seasons and see how it goes. You'll learn a lot of random things. You'll learn that people are really gross. And I worked in the wine industry too, so I saw some pretty crazy shit over the span of like 3 to 4 years. I once had a girl argue with me. She was, we have this thing in British Columbia, in Canada, it's called serving it right. So you have to kind of monitor how much alcohol you're supplying to patrons and things like that. And we definitely had one customer that came in with a little bit too much cheer, And so we're trying to kind of usher her out the front door back to her vehicle. She wasn't driving, she had a driver, obviously, but we're trying to usher her out, and just like she left us just a beautiful present on the front step of all of whatever she ate for lunch that day. So that was fun. Fun stories like that. You do meet a lot of lovely people, and you meet a bunch of weird people as well. Okay, what should we do here? Okay. I have some triangles that are sharing angles. Is that helpful? T to S. I don't know the angle from T to O to S. I have no idea what that is. But something tells me I want to work with like AOT a little bit. AOT. For all of my American viewers, I definitely don't want to work with AOC. We'll try to keep AOC out of this for my American viewers. AOC can get a bit wild, so I think we need to chill. We need to chill it, dial it back, today. So AOT. AOT is 90 degrees. I know that AOT and AOD share angle A. And they have a 90-degree angle, so... Oh, the other one might be shared too, so that means they should share the other angle too, right? I don't get it. That's alright, you don't have to get it. It was just a really bad political joke. That's all. I'm very good with bad jokes. Bad dad jokes. Kind of my forte. Kind of my forte.
Look at this guy.
I think we can probably zoom in though. I feel like we can probably work with AOD and AOT. Something tells me that we need to work in here. And I'm not going to do a very good job of drawing these. Try again. Attempt number 2. Okay, let's just draw one triangle at a time. Oh man. This is how my week is going. Okay, that looks better. AOD. Perfect. Okay, great. And we have T somewhere over here. And we just need to connect this up like this. Okay. Let's throw a 90-degree angle here in red and a 90-degree angle in here in green. So can we make some conclusions? So for triangle AOD, by the way, I kind of want to go to those universities you were looking at. I'm not going to lie. It looked like they had really good programs. They had really nice upper level stuff, right? Like the topics at the 3rd and 4th year levels were really, really interesting. And I think you would really, really like them. There's a lot of variety. You can choose from a lot of different stuff. I think, was it Lancaster? I can't remember which university it was. But the one that actually showed all the different possibilities was really cool. So in AOD, what do we know? So we know that triangle AOD shares angle A with triangle AOT. Okay, so that's a shared angle. They both also have 90-degree angles. Okay, so that's kind of the first noticing. Second noticing is we have angle AOD is equal to angle ATO. So I guess that means that triangle AOD must be similar AOD to ATO or AOT. I think that's the case, right? These two triangles have to be similar. Yeah, and I honestly feel like anywhere you go, I feel like most institutions will be set up similarly. They'll have a pretty similar 1st and 2nd year kind of program. Or at least like the topics or the modules you're going to learn in those first couple years will be pretty standard. Although I found out that wasn't the case yesterday with some of my colleagues here in BC. Like I definitely took I think I had to take 3 statistics classes. And they only had to take 1. And I was like, what? I should have just done my studies in BC because I don't like statistics. Well, I think Reese might be having a nap right now. Should we throw the puppy cam on? We should probably throw the puppy cam on and see if it works. Does doggo cam work? Come on, doggo cam! Work! Oh, there he is. What a cute little guy. I had to adjust the direction it was pointing a little bit, but yeah, he's right in the middle of a hard nap right now. Just having the greatest time. Look at him. That's I would like to admit that, we bought a bed for him, but he never uses his dog bed. He just sleeps on the couch. So I started putting a sheet down on the couch because he's very hairy. And now the couch has become his. And that is how dogs claim things. Loims, hello! How is your day going, my friend? How are you? Welcome on in. We're trying to finish off this question number 8 from the 2019 Euclid contest, and then Noyce has supplied us, I believe, with a couple of binomial expansion questions, which I'm a little nervous about, actually. Going okay so far. I mean, I'll take okay so far. That's better than awful so far, right? And that's better. Okay is good. Okay is good. So if we know these two triangles are similar, they're not congruent, but they're similar. So AOD is similar to ATO. Okay, so that must mean that we can compare sides. However, oh, I know the radius of the circle. So that's how we're going to be able to do this. Okay, so let me draw in some stuff that we know. So we know that AO is 3, and we know the radius. Do we know the radius of the circle? Yeah, the radius of the circle is 1. So this side length here is 1. And what are we trying to find? DS. DS. Is that the same? Is DS going to be the same length as TD? Is Nintendo DS the same length as TD Canada Trust? Is it the same length? It feels like it should be, but it might not be, right? I don't know. AD and DC are off tangent. I guess all these triangles are going to be similar to each other, so it doesn't really matter, I don't think, right? Yeah, maybe let's just convince ourselves quickly that it doesn't really matter. So if I do happen to kind of add in, let's put D here and S here. Let's just try to convince ourselves that this triangle should be similar to the triangle TOD. I think that's true. I mean, they're both 90 degrees. They both share a hypotenuse. So is that enough? If they share a hypotenuse and they both have a 90-degree angle, I think... Is that enough? I think that's enough, right? Sharing the hypotenuse and sharing the 90-degree angle, I think that's enough to say that they're congruent. So if we can figure out the length of TD, we should know the length of DS. So how do we set up the ratio the way we want it to? So if we're working inside of here, we could probably say something like, if we take AO, oops, let's move back to black. So if we take length AO and divide it by length OT, that's 3 to 1. So we need the hypotenuse, and maybe I should just maybe give a highlight to these. So we're gonna go, it's gonna be our what triangle am I using? So we need to compare this one to this one. Okay, yeah, I think we can do this. So AO compared to OT, or AO over OT, that should be 3 over 1. This should be in proportion to AD, so AD over, I need the hypotenuse over the smaller side length. Okay, make sure I get the right leg. Is this going to be OD? Why is my brain is so not functioning today? I think we need the smaller of the two side lengths, right? Does that seem reasonable? I think that's right. I don't know if we can use that right away. Right, all I know is that this proportion should be equal to 3. But I don't know if I can get in there right away without doing some Pythagorean theorem first. So from A to D is A to T plus T to D. T to D is the thing that I want. OD. Again, I don't really have a lot of information about OD, but I probably could find AT using Pythagorean theorem. So let's try that. So I think we can probably do something like AO squared plus OT squared. Try again. AO squared should be equal to OT squared plus AT squared. That should be a Pythagorean theorem we can do, right? That's the red, the highlighted red triangle. This is triangle AOT. So AO squared is 9, OT squared is 1. So AT squared should be 9 minus 1, which is 8. So AT will take as positive root 8. So that we can do. Now, if the ratio of A over D to OD is 3, we could probably say that A to D should be equal to A to T plus T to D over OD. And now that I know what AT is, I can substitute that in. However, is it possible for us to start figuring out what else do I need? I need I mean, if I had OD, we could solve for some stuff, right? Is it possible to get that? I think it might be now that we have the root 8, right? We know all three. If we have all three sides and we happen to know one of the other sides, we should be able to get the rest of the... We might not even need the similar triangle argument, to be honest. I might be able to kind of skip over this, but let's see. So if... I need to kind of zoom in now. So if we know that triangle AOT has sides in order from smallest to largest of 1... hypotenuse is always the biggest, right? So if triangle AOT has this order, 1, root 8, and 3, is it possible for us to do some division and figure out what the ratio of TOD should look like? I think we can do this. Now, the smallest side length is going to be TD. That's what we're looking for. The next side length we need is 1, and then the biggest side length is going to be OD. So I think if we take AOT and divide everything by root 8, is that how similar triangles work? Levi, hello, man. How you doing? Are your exams done yet? Exams are over? Almost. Oh, that's a hard no then. Hard no. But I like your optimism. I appreciate it. Numerical analysis on Thursday. It'll be a walk in the park, he says. A walk in the park. So, my question is this. Is it true? Do we think that TOD should be in similar ratio? So if we know that the longer leg is 1, the shorter leg is going to have to be 1 over root 8, right? And OD is going to have to be 3 over root 8. Does that feel like a truthful thing? And I mean, I can't imagine that they're going to want this answer as 1 over root 8, so we could probably take 1 over root 8 and I multiply it by, so we could do root 8 over 8, which is, we could take a 2 or a 4 out of there. So 2 root 2 over 8. So what is this? Root 2 over 4? I mean, it's quite possible that I could have gotten a little backwards while doing some of this stuff, but that doesn't seem unreasonable. Let's take a look. Let's take a peek. So, solutions. I feel like I probably fucked up an angle somewhere, but okay, yeah. So yes. OT is 1, right? Not Pythagorean theorem. AT is root 8. So we got that. Perfect. So since, what is this? So since right angle, okay, yep, TAO equals DOT. Yes, okay, that means that we have similar triangles. Similar triangles tell us that dt is 1 over 2 root 2. That is that, wait, is that what we got? Is that what we got? 1 over 2 root 2? Is that what we have? 1 over 2 root 2? I think so. Nice. Okay. Okay. Look at us. Look at us go. We got this. We got this. It's a good day. It's a good Tuesday. We can do geometry here. Geometry is a thing that's possible. And now we take a break from geometry for a word from our sponsor. Apparently our sponsor is trigonometry. Vintage Luigi. Oh my goodness, a blast from the past. Well, come on in, my friend. How have you been? I feel like it's been several millennia since I've heard from you. Hopefully all is well on your end. Give me an update, man. Give me an update. How are things over there? How's vintage Mario? Oh, Levi, that's nice. I actually kind of like it when you have props that do that, when they are like, here's a practice test, and the practice test gives you a pretty good idea of what to expect on the test. I like when props do that. It definitely makes your life as a student a little bit easier, doesn't it? Same old, same old. Still saving the princess from Bowser. Tutoring locally. Cool. That's really cool. Tutoring locally, you say. Tutoring locally. Interesting. Who can remember the binomial expansion? I cannot. I know that if I say that out loud, Levi's probably going to be one of the first people to tell me what the formula is. Something choose something? Something choose something? There's an actual formula for this though, isn't there? Isn't it? Is it a summation formula? NCR. So it's N choose R. I might have to look it up. I feel like it's going to be one of those things that's probably just binomial theorem. I should just look it up. I'll just grab the formula and then we can give it a shot. Mathisfun.com, sure. Ooh, okay. Okay, let's just write that down. So a plus b to the n, and it's the sum of, I believe it was n choose k, and so k is going to be our index that ranges all over the place, so it should start at 0, go up to n, that makes sense. And we have we have one of them that's going to be to the n, or to the k, I guess. Yeah, so we have one that's n minus k and one that's k, right? Because these should add up to n.
Time for a pop quiz.
Dr. L, welcome to the channel. How are you doing, man? Isn't that like growing and shrinking? What? Growing and shrinking in the exponents for coefficients and variables. What? So how are we going to get this set up? We need... That's weird. I'm going to be like, A is equal to AT. And B is equal to t to the 1/2. And we need the coefficient of t to the 7. T to the 7. Loins, just keep expanding it out. Not a chance, not a chance.
Use X and Y, not A and B.
Oh, that's a good idea. X and yeah, I like that. Okay, X and Y, not A and B. Sure, we can do that. Good ideas. Good ideas all around, except for those of you that said expand it out. Those are bad ideas, poor ideas.
Wrong.
We definitely should not be expanding this all out. Okay, so what do we have? We have something that looks like AT minus t to the 1/2 to the 9 should be the sum of k ranging from 0 to 9 of 9 choose k. X is AT. Okay, we need to raise that to the power of n minus k, 9 minus k. And y is t to the 1/2, and we need to raise that to the power of k. So our goal is to try to find the coefficient of t to the 7. What is that crying face? Get out of here. I'm not expanding out something to the power of 9, not a chance. I want to cleverly think through this. I feel like there's going to be probably 2 terms we have to look for, right? So we need to figure out when we're going to have a power of 7. So let's do a little bit of simplification on the right-hand side here and just kind of see what's happening with our powers for t. So if we do something like this, I'll just leave all this the same. This is going to be a to the 9 minus k. We're going to have t to the 9 minus k, and then t to the k over 2. Not k minus 2, k over 2. And we should be able to combine these two things, right? So we can add these together. So 9 minus k plus k over 2. What's that equal to? 9 minus k over 2? Does that sound right? So I think that's the play. I think we need to figure out what potential values of k are going to give us a power of 7, right? So this is the power of t here. And what do we need? Do we need k is equal to 4? That's the only one that'll work, right? K is equal to 4? Okay, so I think that kind of solves the first problem. What value of k is this going to work? So we need k is equal to 4 for t to the 7. So let's try to sub that in. If we do that, we're going to get 9 choose 4, a to the 9 minus 4. And it's going to be t to the 7, right? Because we've solved for a specific value of k. So t to the 7. And so simplifying this other stuff should give us the coefficient of t to the 7. I have no idea what 9 choose 4 is, but we can probably figure that out. This is 9 factorial over 4 factorial 5 factorial? Is that how that works? A to the 5? Something like that. That's, oh goodness. Okay, so this is 9 times 8 times 7 times 6. The 5 factorials cancel. And then we have 4 times 3 times 2. 4 times 2 is 8. So we can probably do something like that. We can get rid of one of these factors of 3. So we have something like 18 times 7 or 21 times 6 or... $42 times 3? Get rid of the 6, he says. What? It's easier to get rid of the 6? Mentally, is that what you're saying? So 126a to the 5 is our coefficient. I think that's how this works. 126 loins, yes. And make 8 a 2. Oh, I see. So you're thinking if we do 9 times 8 times 7 times 6, and we had 4 times 3 times 2, you're saying it's easier if we do this and this, and then we can get rid of one of those 2's, I guess? Is that easier? 18 times 7, 14 times 9. What's 9 times 7? Nine times 7 is 63. 63 times... Yeah, I guess that's easier mentally, right? That's going to be 126. Yeah, okay. All right, I got you. Yeah, working with 2's is a little bit easier than working with 6's. Totally, I get it. Okay, I think I'm happy with that question. I think I'm happy with that. How do we feel? Do we feel happy with that? I feel pretty good about that. I feel like we did a thing. So I feel like that's how we tackle something like that. Use the formula, figure out the value of k that's going to give you, in our case, t to the 7, and then just try to simplify for that coefficient. Okay, that's a cool question. I like that a lot. This one's a little bit more intense, I'm not going to lie. This one scares me a little bit. Like if it was October, I might have a Halloween costume idea, and it might be this question. I would probably just try to dress up as this question. So here we go. We know that a minus k times x to the m, all raised, so it's a binomial raised to the power of n, has the following expansion. We need to find the value of p. Find the value of p, which probably means we're going to have to find a, k, m, n, and q along the way. Plug in good values. Let's just make every parameter equal to 0. Let's just... Does 0 work? I don't think so. I don't think it works. Okay. What do we know right off the hop, though? What we do know right off the bat is that a to the n should be equal to 243 over 32. We do know that right off the bat. And in addition to that, I have to be a little careful here because I think we're going to have to take the negative in too, right? Like negative k x m. If I raise this to the power of n, this is going to be the largest power of x. And is this in order? 3 halves, 1.53, 4.56. So I guess this is going to be equal to negative q x to the 15 over 2. So we have a couple equations we can use right off the bat. Plug in x equals 1. So we've done x is equal to 0 already. This is x is equal to 0, I assume, right? X is equal to 0 is just going to give you the constant. So yes, so that's subbing in x equals 0. What if we do put x is equal to 1? That's actually really interesting. So if x is equal to 1, what do we get? We get a minus k to the n is equal to 243 over 32 minus 405 over 4 plus 540 minus 1440 plus p minus q. So I believe that's what we get if we set x is equal to 1. That still has a lot of damn parameters in it. But it's definitely a usable equation. It's usable. Okay, I'm going to put that on the back burner for a hot second because I'm not exactly sure how easy this particular equation is to use right away. It's not obvious exactly how to use that. It is a little bit more obvious to me, I think, how to kind of work with this second equation I have up here. I think if I distribute that power of n through, we could get something like negative k to the n, x to the mn is equal to this, right? So we could probably reasonably conclude a couple of things. We can probably conclude that negative k to the n should be equal to negative q, and that mn multiplied together should be 15 over 2, 7.5. So that at least gives us a couple of equations we can work with. Is there an easy way that we can... I mean, we do have some other... I mean, we have some of these middle terms, right? Yeah, is it possible to rewrite this as something to the power? This looks like 2 to the 5 down here, personally. 32, right, is 2 to the 5. Is 243 something to the power of 5? It feels like, is that 3 to the 5? 2, 4, 3, 7, 9. It's divisible by 3. So is this 81 times 3? Okay. So that's helpful. That's going to give us A and N. Sweet. Okay, so we have a couple of values right off the bat, so that's actually quite nice. So I'm just going to give them a little bit of a square here, a little bit of a rectangle in red. If we have n, we should be able to solve... Should be able to solve for m, right? So I'm still going to move this down because this might be helpful in a second. Let's throw that down here. Let's move over to mn is equal to 15. So we know that n is 5, so 5 m's is 15 over 2. I think that's going to tell us what m is, right? What do you mean it's not certain? Yes, that's true, but I think if we force n to be an integer, that should be the only solution, right? I agree with you. But I think n, yeah, I think Dr. L is correct. I think n, for the binomial theorem to reasonably work with real numbers, I think we need it to be an integer. At least for our formula to work, right? Otherwise, we need to get a little crazy with more complex complex formulas, which I don't think is what Noyce is studying. I mean, I could be wrong. Wait, does this give m is also equal to 3 over 2? That's weird. So if we divide both sides by 5, we get 15 over 10. So m is also 3 halves? That feels weird. That feels weird. I don't know if I like it. I don't think we can tackle the k and q problem yet, though. Even if we know n is 5, all we know that then would be that negative k to the 5 should be equal to negative q. So k to the 5 is going to be equal to q if we kind of cancel out those negative 1s. So that's the best we can do there. But we do at least have a, n, and m now, which gives us a little bit of firepower. Does that help us down here? We know a and n. We don't know k, but we could put k in as k to the 5. So I still don't see how the x equals 1 is helpful yet in green. So I still don't think that that green equation is going to be helpful quite yet. I think we might have to go back to the drawing board and we might have to try to use, like, this x to the 3 seems really enticing to me. I don't know why, it just feels really enticing. Like, I kind of want to use it. I wonder if we can use that to solve for k. If we can solve for k, we can solve for q. We don't really need q. But I need one or the other. I either need Q or I need K in order to get to P, I think. Because this term in here is going to be a cross term of some of this stuff. So maybe let's use the 540. So I think you're right, Levi. I think let's use the expansion. Let's try to get the x to the 3 term maybe and see what happens. Let's see if I can write it out proper here. So what do we have here? We know A is 3 halves. We don't know K. X to the 3 halves. N is 5. Okay, and all of this should be equal to the sum as, oh, they've used K again. Okay, so let's let I range from 0 to 5. And this should be 5, choose I. We take the first thing, which is 3 halves, and we go 5 minus I. And then we take the second thing, which is negative k x to the 3 over 2, and we raise that to the power of I. I think it's something like that, right? So this is the expansion. And let's find, let's use the fact that we have 540x to the 3. Well, considering our first term A doesn't really have any x's in it, it should be relatively straightforward to see which value of I that we need, right? So we need x to the 3 over 2 to the I to be equal to x to the 3. So we need 3I over 2 to be equal to 3, so I must be 2, right? So when I is 2, we should get the coefficient of 540. Okay, what did I write down? So we should have 5, choose 2. We should have 3 halves to the 5 minus 2. And then we should have negative k x to the 3 halves I, but I is 2. So let's throw that 2 in there. All of this should boil down to 540 x to the 3, if we're lucky. I is 1? What? I is 1? Holy moly, look at everyone jumping in here. Eder, hello, how's it going? We're doing some binomial expansion. We're trying to solve for some parameters here, trying to double check some work for Mr. Noyce. Sensation, hello, welcome on in. How are you doing? It's been a long time. Hopefully you're doing well. 1984, that was a good year, my friend. That was a good year. Oh, did I mess up? Did I done mess up somewhere? I mean, we don't have to pick the 540. We could pick feel like we could pick any one of these. It doesn't really matter, right? You can make a choice on which one you want to use, but you're going to have to use one of these middle terms, I think, in order to solve for k. I think. Oh, you're still working on the whole M and N thing. Yeah, okay. That's all right. That's cool. I like to use the method known as cheating. Did we do our expansion correctly, though? It should be negative k x to the 3 halves to the I, right? So x to the 3 halves I. So I should be 2, right? I shouldn't be 1. I feel like I should be 2. And if I is 2, we have 3 halves to the 3, negative k x to the 3 halves to the 2. Yeah. Okay, yeah. So we have 5 factorial over 2 factorial, 3 factorial, 3 to the 3, 27 over 8, negative k squared, x to the 3. Okay, so you are now happy with M and N? So obviously we get the x to the 3's that we need. Here, what do we have? We have 5 times 4. Let's get rid of the 3 factorial. This is just going to be 2 times 1. So this should be 5 times 2, which is 10, times some stuff. So we'll get like 270 over 8. We're going to get k squared, because the negative one doesn't really matter. All this should be equal to 540. Eight only has 2's in it, so let's see, how many 2's can I get out of 270? Probably just 1, right? Yeah, so that'll give me 135 over 4. Now, the question is like, if I do all of this work and I don't get a squared number, I'm going to be so upset. What is 540 times 4 divided by 135? Yes! This is how you know you've done it properly, right? This is usually how you know. Oh, cool. I didn't even see that. Yeah, 540 divided by 270 is 2. Multiplied by 8 is going to give you your 16. Nicely done. So we have k is equal to 4. K is equal to 4. Or I guess it could be negative 4 too, but let's see. It just says that k is a constant, so I suppose... Could k be negative 4? Could k be negative 4? Well, I guess it could be negative 4. Depending on what the value of q is. That just means q is going to be a negative number, right? So k technically, I guess, could be 2 different possibilities. Plus or minus 1. Whew. It's getting spicy in here. Okay. So now that we know k... we should be able to figure out the values for q. If k... okay, so if k is plus or minus 4, we know that q should be equal to plus or minus... k is 4. It can't be negative 4. Negative 4 or 5 over 4 x to the... Oh, okay, okay. Yeah, I see. So since you have alternating... Okay, I got you. Yeah, so since you have alternating signs, we're forced to pick k is equal to positive 4. I got you. Yeah, okay, that's great. That gives me much more confidence. Okay, no, that's perfect. So the argument here is... Okay, we used this one to solve for k. But since this is an odd term, k has the possibility of being both plus or minus because we have the k squared that pops out. But since this term here, which is the second term in the kind of expansion, is negative, we know that k actually has to be positive here, so that we do get the alternating plus and minus signs throughout the expansion. So that is important. Thanks for that, for clarifying that. So if k is plus 4, that means that q should be, I believe we had an answer 1024. That seems about right. Right? It should be 4 to the power of 5, which is 2 to the 10? Is that 2 to the 10? 2 to the 10? Is that right? 32, 64, 128, 256.
Time for a pop quiz.
No, no pop quizzes. It seems like that's reasonable. Yeah, it seems that we should get up there. 70. 70. Is that our answer? 5 times 12 is 60 plus 10. Bam, 70 it is. Okay, so if we happen to know the value for q, can we solve now for p? That is the question. So we know what k is, we know what m is, we know what a, m, n. We know all of our parameters. We should be able to do the same thing to solve for p. So that's going to be our last step. Let's get ourselves a little bit of space, and we know that we have 3 halves. I believe it is minus 4x to the 3 halves. And then this was 5, right? Yeah. So 5 should be equal to the sum of, we have I from 0 to 5. 5 choose I. I needed 3 over 2 to the 5 minus I. And then negative 4x 3 halves to the I. And we know that we should somewhere have px to the 6, I believe. It was a positive one, right? Positive px to the 6. So for what value of I are we looking for? I'm assuming we're going to need I is equal to 4. Seems pretty obvious to me. So the fourth term in our sequence here should give us px to the 6. So let's sub that in and see if we can solve for p. So we need 5, choose 4. We have 3 halves to the 5 minus 4, so the power of 1. And then we're going to have negative 4x to the 3 halves to the 4. And this should be equal to px to the 6 if we've done everything correctly. 5 choose 4 is just 5, isn't it? What is 4 to the 4? 4 to the 4. 16 times... That's just 16 squared? What is 16 squared? I should know that. Limes, yeah, I think that's kind of this. That's at least a strategy that made sense for me. Yeah, it was kind of picking one of those middle terms, trying to solve for some of your other parameters, and eventually work your way over to p. Because what you need in order to use the binomial theorem here, what we need in order to find, say, this term over here, is we need to know what all of these parameters are: a, k, m, and n. If we happen to know all of those, then it's relatively straightforward to find the value for p using our formula. So that's why we spent a lot of time at the beginning trying to get some of these parameters. Because if we do have them, then it becomes pretty nicely determined what these other parameters P and Q should be. So what do we need? We have 15 over 2, and we have, what is 4 to the 4? 1920? 1920? That's not right. 16 times 16 is not, that's way too big. 256. Oh yeah, it should be a multiple, it should be a power of 2. Right, okay. So 15 times 256, divide that in half. Wait, that's not right. 15 times 256, divide that in half, should be 1920. So P is equal to 1920. Sweet. Holy moly, that took a while. That's an intense question. Now, that's a pretty well-designed question. Uh-oh. And Noyce is like, hey, by the way, since you've solved all this stuff, we should just do another one. What time is it? It's already 2:10. It's 2:10, my friends. It is 2:10. We've solved some binomial theorem stuff. Excellent. We are going to move forward. We're going to probably start working on 9 and 10. You know what? Why don't we get 9 set up? I want to finish this 2019 Euclid test before I go on vacation in a couple weeks. And I know I'm going to need probably a couple days to start thinking through some of these questions. And Andy's doing some fun. Oh my gosh, there's so much fun stuff happening right now. Why is April so challenging and so fun at the same time? So, question is, if we start number 9, can we potentially squeak through A or B? Levi, when do I work at the new place? I've started working at the new place for the last 2 weekends. So I will be back on Saturday. My shift on Saturday is 12 to 8. And I think I'll be probably Saturdays and Sundays after I get back from my vacation. So I'm going for a little vacay in May here. So I leave on, I think, the 8th, and I get back on the 16th. So I'll probably work, I think I'm going to work like the 29th and the 6th. And then when I get back, it'll probably be Saturday, Sunday. So probably starting the 20th, it'll be Saturday, Sundays. Which I'm pretty stoked about. I had a lot of fun last weekend. Yeah, honestly, just like come up, pop up a spot on the bar. Like, the bar is a great place to study. Whenever I want to go do work, I always just work at like the end of the bar. And then I try not to get distracted by people. So what is this? For positive integers a and b, define, we're going to define a multivariable function. F of a and b is a over b plus b over a plus 1 over ab. So for example, the value of f12, let's just double check this. So f12 should be 1/2 plus 2 over 1 plus 1 over 2 times 1. So we have 1/2 and 1/2 plus 2, so that should be 3. That checks out. Okay, so I'm happy with that. So part A just says determine the value of f25. That's just a simple substitution. So f25 should be what? 2 over 5 plus 5 over 2 plus 1 over 2 times 5, which is 10. So yeah, I agree with you, Loims. There's going to be something here about common denominators that feels important, right? Something about common denominators feels important. So obviously we're going to have to convert all of these to tenths. However, it could get tricky when a and b have shared factors. I mean, if a and b are prime, then it's relatively straightforward. But I mean, we can still work algebraically with that thing, even if they share a factor. But anyway, yeah. So this will be 2 times 2, which is 4. This will be 5 times 5, which is 20. Oh, I see. So you're gonna always get the squared terms up top plus an extra 1. So 29. This will be 30 over 10. What? This can't always be 3, right? There's no way this would always be 3. It's weird that that also comes out to be 3. Okay, well, let's start setting up B. So B asks us, determine all positive integers A, for which FAA is an integer. So we need A over A plus A over A plus 1 over A squared to be an integer. Is that true? So we need 2 plus 1 over A squared to be an integer? So doesn't that mean that we need 1 over A squared to be an integer? Is that it? Is it just 1? That's the only one? Am I going crazy here? Is that the only one we can do? That makes sense, right? Because I mean, if B is equal to A, then you just get 1 plus 1 plus 1 over A squared. So you get 2 plus some stuff. 2 plus some stuff. I think that's the only one that works. I think. This seems really cool, though. If A and B are positive integers, and we know that FAB is an integer, prove that it has to be a multiple of 3. That's kind of interesting to me. So if it comes out to be an integer solution, it has to be a multiple of 3. Cool. So every time we get an integer solution, it has to be a multiple of 3. I feel like I can probably prove this relatively quickly right now. I feel like it's not, I don't think this is going to be too crazy. And I think we can probably do it using, I think Loyms had suggested if we find a common denominator of AB, right? So we have this plus this plus this. And if we do this and this, we can probably convince ourselves that we get A squared plus B squared plus 1 over AB. And now let's use the assumption. Let's use the assumption that when we evaluate this, we do get an integer. If that's the case, that means that A squared plus B squared plus 1 should be evenly divisible by AB, right? We should be able to take A times B and multiply it by some integer. to get to a squared plus b squared plus 1. So we know that, for example, we could just call it like k or something, right? Like we could say like k times ab should be a squared plus b squared plus 1. Right, and k is some integer. It's not as obvious as I thought it was going to be, though. So what do we have? We have sum of 2 squares plus 1. So the sum of 2 squares plus 1. But it does, I guess, give us some information about... I have to be careful about this. I think we're going to have to go with cases. I think we'll have to go with cases. And I probably will do this. What's tomorrow look like? Tomorrow's Wednesday. I have to mark the Euclid math contests tomorrow, guys. Tomorrow is the first day of marking for the 2023 Euclid math contests.
Oh yeah? Prepare to be iterated.
What? Dr. L, thank you very much for the follow. Much appreciated. Welcome to the Epsilon crew. And thanks for hanging out today. I love the fancy L. L spaces, right? I do think we're going to have to... I'm going to leave it here, and I think we'll probably have to do some cases, right? Because I think that...
You're an odd function. Try this composite function.
I like Angry Show, I'm not going to lie. I think it's going to be something to do with this K, right? Because, like, I'm going to have to go back and think about number theory again. But, I have, like, 3 divisors of a sum of numbers. So, I know that, for example, A is going to divide this, B is going to divide this. So, we're probably going to have to walk our way through some cases and be happy that, if A divides this, then it probably should also divide this. It's going to be one of these weird things, right? Because I have a sum on the left-hand side. So I think we're going to have to try to throw some number theory at this and some divisibility theory at this. But I'll leave this for you guys to think about over the next day or two. Tomorrow, what does it look like? Tomorrow, if I do stream, it'll be an early stream because I need to be at the college for 1. The other option is I could stream later tomorrow. So I could stream when I get home. So I think if we stream tomorrow, it can't be at 3 because I have some interviews tomorrow. So if I stream tomorrow, it's either going to be early, so at like 11 a.m. BC time, or it could be at around like probably 6 or 7-ish when I get home. Probably later is preferred for me. What does Thursday look like? Thursday is going to be busy again, so I think what we're going to have to do this week is probably postpone some of these sessions to a bit later in the evening. So I think probably 7 p.m. starts over the next couple of days. So plan for that. I think that's going to be the easiest based on kind of all the meetings that are being slapped onto my schedule for some reason this week. So let's aim for maybe 7 p.m. starts over the next couple of days. We'll try to finish off the Euclid contest this week. And that'll open us up for, by the way, a little bit of work with Andy's channel, right? So I do want to kind of come through, see what Andy's been up to over the next couple days and see if we can help him out thinking about some of his problems too. So he has a lot of really fun problems here. If you want an invite into Andy's channel, let me know. We can pop that up into the elements, maybe into the general chat, and you guys can pop over into Andy's channel if that's something that you are interested in doing. So until tomorrow, stay positive, guys, and we will talk with you. We'll talk with you very, very soon. Thanks for the hangouts, as always. We'll sit here for a second. We'll chat. Hey, Dr. L, no worries, man. I actually have. I didn't know how I would feel at first about streaming mathematics, but we've grown a little community of some solid people that love just kind of getting together, talking about math, solving some problems. Keeps me up to date with kind of what's happening in the math community, so it's been a lot of fun. So hopefully you guys have appreciated the streams as well. Levi, if I don't see you tomorrow, good luck on the exam Thursday. Let me know how it goes. And yeah, we'll plan to get together hopefully at some point in May. And then I think I'll have a better idea of how to move forward with some of the tutoring stuff if you want to kind of open up that chat again later in May. All right, so not seeing anything specific in the chat. I'll let you guys be and go enjoy the rest of your day. I will talk to you probably tomorrow night. All right, peace out, guys, and take care.